This is a lesson on the introduction to differentiating trigonometric functions. The learning outcomes are, number one, differentiating basic trig functions. If you differentiate sine, follow the black arrow, the answer will be cos. If you differentiate cosine, follow the blue arrow, the answer is minus sine x. If you differentiate tangent, follow the red arrow. When you differentiate tan, you get sec squared x. Second learning outcome is making use of the product, quotient, and chain rule when differentiating trigonometric functions. And the third learning outcome is making use of trigonometric formula to solve calculus problems. On the right-hand side, you've got the exercise 13.6, page 340, with the numbers indicated underneath for what you have to attempt by the next lesson, and make every effort to get right. Now we'll move on to some examples. When you differentiate basic trig functions, it is best to learn this simple rule. When you differentiate a sine, you'll get a cos. When you differentiate a cos, you get a minus sine. And when you differentiate a minus sine, you will get minus cos. When you differentiate minus cos, you go all the way back to the top and you get sine. So when you get to the bottom of the list and you're differentiating minus cos, it means you go all the way back up to the top of the list and start all over again. In exam situations, it is best just to write down SC minus S minus C and then go from there. You'll see it in practice on the next page. Okay, so here we are. You're in an exam situation and you get asked to differentiate trigonometric functions. The first thing you should do is, in the corner, write down SC minus S minus C. To remind you, if you're differentiating sine, it becomes cos. If you differentiate cos, it becomes minus sine. And if you differentiate minus sine, it becomes minus cos. And if you differentiate minus cos, it goes back to the top and comes sine again. So I'm now going to differentiate the first problem. When you differentiate y, you write down d for differentiation, dy, and if you look at the variable on the other side, it's an x, so it's dy with respect to x. And from our little memory thing on the left, when I differentiate a sine function, I know it becomes cos function. So there it is, there's the answer, cos x. I'm now differentiating the y. So I differentiate the y with respect to, and this time it's with respect to theta. So it's with respect to theta. And then I go back to my list of letters, and according to my list, if I differentiate cos, I get minus sine. So the answer is going to be minus sine theta. And then here, I'm differentiating the y again. And I'm differentiating it this time with respect to t, the function t. And go to my list, and minus cos at the bottom. If I differentiate a minus cos, I go all the way back to the top, and I get plus sine x, plus sine x. Sorry, I beg your pardon. In this case, it's sine t, sine t. Now, on these ones down below, they're going to be slightly more difficult. The first thing is recognizing that it is actually the chain rule. And technically speaking, I'm just going to rewrite it into its correct format. F of x is equal to the cos of 4x So I've got two functions. One is cos, and inside it, I've got 4x. So this is my priority A function, and this is my priority B. And the chain rule says that you differentiate your priority A function first. Going to my list, and I differentiate cos. When I differentiate cos, it becomes sine. So therefore, I differentiate my priority A function, and when I differentiate cos, it becomes sine, and then nothing else changes. And then I open a bracket, and in here, I'm going to be putting the differential of B. And the differential of B is a differential of 4x, and the differential of 4x is 4. So therefore, f dash to x, rewriting it, is you bring the 4 to the front, and it's 4 sine 4x. And that's the end of that particular problem. Okay, moving on to the next one. We've got here h of x is equal to the root of sine x. And you had to spot here, this is the trick on this one, that we replace the square root symbol with a bracket, and we replace the power with a half, because square root means a power of a half. Now, remember, unwrapping the Easter egg, is the priority function is now the half, and the secondary function is the b. So we have to differentiate priority A function first. How do we differentiate a power? Well, it's very simple. We multiply by the power, and then we put the power down 1. So take 1 away from a half, get minus half. And what's the trick with chain rule is whatever was inside does not change. And now what we've got to do, brackets, we've got to multiply by the differential of the b function. And of course, the differential of sine is cos. So the differential of sine is cos. So therefore, I'm multiplying by cos x. And that's, just tidy it up, h dashed x is equal to 1/2, open bracket, sine x to the power of minus a half on cos x. And that's a perfectly acceptable way of writing it. Now, we're going to go on and we're going to do the tan x. So the last one is we've got g of x is equal to tan power of 4, open bracket, 3x. Now this is a bit of a trick question, because you've got to remember that when we write powers of 4 like this in trigonometry, it's actually incorrect way of writing it. We only write it like that for convenience. And you've got to remember that when you actually type it into a calculator, then you've got to type it in like this. Brackets round the tan and power of 4 at the top. Now, what does this mean? Well, it means if we're unwrapping this function, the first thing we want to unwrap is going to be the letter A, the power of 4. which means we're going to call that our priority a function. That's the first one we are unwrapping. Once we unwrap the power of 4, then we're going to go inside, and we've got tan on 3x. So this time we are going to be focusing on the b function, which is tan, and then finally the c function is equal to 3x. So we're now going to differentiate. This is the worst you're going to get in the exam. So differentiating g, and we get g dashed x. Our first focus is the power, and what do we do with that power? We multiply by the power, and then we put that power down 1, and nothing else changes. Now we're going to look at the priority b, and the priority b is tan. And we have to go to the formula books, and we have to look at page, I think it's 23. No, it's page 25. And when we look at page 25, we should discover that when we start off with tan x and we differentiate it, it becomes, according to the formula book, it becomes sec squared x. So when we differentiate tan, it becomes sec squared. Now that is in the formula book. So here I do my bracket, I differentiate the tan. What's it become? It becomes sec squared, and nothing else changes. The 3 on x remains the same. And then finally, we're going to be multiplying by the differential of c. Now, since c is equal to 3x, the differential of c is going to be equal to 3. That's the line you have to work out, and that's the line you have to learn. Now, what you should do in a real exam, of course, is tidy this line up. So what we have now is we've got g dashed x is equal to, the 3 comes to the front, 3 4s are 12. And then we're going to have tan 3x, all to be cubed on sec squared 3x. And that would be a perfectly acceptable answer. Okay, we move on. Now we've got a slightly more complicated function here. Well, actually it's the same as the last one, to be fair. So what we have here is we've got g of x is equal to cos to the power of 4, open bracket, 3x. And once again, we have to remember that the power of 4 is actually written incorrectly. And we just do that to make life easy for ourselves. The actual real meaning of this is cos of 3x, all to the power of 4. So it's very important, once again, we saw it in the last example, and you're seeing it here, that you learn to write it in the correct way, because then you'll see that the power is now the priority function, the cos is the secondary function, and the 3x is the third one. Over here, I'm going to write my little memory thing, sine, cos, minus sine, minus cos. And when I'm coming down this line, I am differentiating. Okay, so let's do this. So g dashed x is equal to multiply by the power and then put the power down 1. And remember, What was inside the bracket is still inside the bracket, no change. Multiply by. We're now focusing on priority b function, and the priority b function is a cos function. And when we differentiate a cos function, we get minus sign. So we now know that this cos is becoming a minus sign. The only thing that changes is the b part. What's in brackets remains once again unchanged. And now we're working on the priority c function. And the priority c function is we multiply by the differential of what's inside. And again, that's the end of the problem. You get full marks for that. But here's a tidy up line. A 3 on a minus is minus 3. A 3 on a minus is minus 3. And then a minus 3 on 4 is equal to minus 12. It's minus 12, open bracket, cos, open bracket, 3x, close bracket, to the power of 3. Do that neatly. To the power of 3. Don't forget, we've taken care of the 3, we've taken care of the minus sign, we've taken care of the 4. So all that's left to write here now is the sign of 3x, and then we finished. Okay, moving on. We've now got to differentiate x sine x. So we've got f of x is equal to x times sine x. And in this case, you had to recognize that this is the product rule. First times second. And at this stage, I hope you've learnt that for the product rule, it is the first function times the differential of the second plus the second function times the differential of first. You really need to learn that rule in words. The first function is equal to x. The differential of the first function, therefore, will be equal to 1. The second function is equal to sine x. So over here, sine, cos, minus cos. So therefore, the differential of the second function, sine to cos, is cos x. So all we have to do now is work it out. So dy dx is now equal to, what is the first function? Well, it's x. What's the differential of the second? Well, it's cos x. Plus the second function. The second function is sine x, multiplied by the differential of the first, which is 1. Quick tidy up line, dy dx is equal to x on cos x plus 1 times sine x, which is quite simply sine x. And that's a very straightforward problem, as long as you spot that it's going to be a product rule. And it says, up here, it now says for part 2, hence, find the slope of the tangent. Find the slope of the tangent. Finding the slope of the tangent means finding dy dx, which we've already done, at the point where x is equal to pi. So basically, on that question up there, we now know that x is equal to pi. So now they want me to find the slope of the tangent, which is the slope of the curve, when x equals pi. So we now do that. And now what I need to do is I need to either use my calculator or I need to turn to page 13. Page 13 of the Formulas and Tables book to find out what cos of pi is. And when I look it up on that page, it tells me. And it says cos of pi is equal to -1. And now I'm looking up sine of pi. And on that page, it tells me that the sine of pi is equal to 0. So now I can come back here and I can write down pi, open brackets, well, cos pi is -1 plus, and sine of pi is 0. So the answer is quite simply minus pi. And it really couldn't be any simpler than that. Okay, moving on to the next example. So now we've got to work out, find f dash x, the derivative of the item above, and then write it in this form. We'll worry about that later. Let's just pick up some marks. So the first thing is I've got f of x f of x is equal to sine to the power of 4 on x plus cos to the power of 4 on x. The next thing is we're going to be changing that because that's incorrect notation. We said this earlier on, that power is always written in the wrong place. So we now write it as sine x all to the power of 4 plus, open bracket, cos x all to the power of 4. Now we're going to differentiate, and the priority function is going to be the 4. So that's going to be what we call priority function A, and therefore the sine x is going to be priority function B. Over here, sine, cos, minus sine, minus cos, ready for when I need it. So multiplying by the power and putting the power down 1, and what's inside does not change. And then you multiply by what's inside, and the derivative of sine is cos x. And then over here we're going to be doing plus, and then once again the priority function is the 4. So we label that A, we label this B. Differentiating the power of 4 is going to be 4, and then put the power down 1, and what's inside does not change. And then the derivative of cos is minus sine x. So that's the first line done. Now we're just going to tidy it up. F of x is equal to 4 cos x times sine. We're allowed to write the 3 back in there again. X plus on a minus, a plus on a minus is of course a minus. It's going to be minus 4, and then it's going to be sine x, has no power on it, so I'm going to write it at the front. And then the cos x has a power of 3 on it, so we write that as cos cubed x. Now we know we haven't finished because this thing here doesn't match the answer. So when in doubt, factorize it out. So 4 is a common factor, and cos is a common factor. So we can take out cos x as a common factor. And we've also got sine is common to both. We have a sine here. We have a sine here, we have a sine there, so we have a common factor there, and of course the common factor we've already established is sine x. So we've taken out a cos x, so there's no cos x left. We've taken out a sine x, so there's sine squared x left. We took out the 4, the 4's gone, the sine's gone, and one of the coses is gone. So we've got cos squared x, which still is not in the format we wanted in. So now we go to the formula book and we go looking for formulas. And what we do have is we've got cos squared on page 14. On page 14, a bit mean of them actually, on page 14, very mean of them, we've actually got cos 2a. It's very similar to what we have here, is equal to cos squared a minus sine squared a. And this is quite horrible because you had to spot that if you multiply everything by a minus, that sine squared becomes a plus sine squared a, and that cos squared becomes a minus cos squared a. And we know what's in the bracket now. What's in the bracket is going to be cos 2x with a minus sign. So we've now got equals 4 cos x sine x on minus cos 2x. Now, again, rather mean, because if you spotted it, you're home and dry. 4 is 2 2's. So I've actually got here 2 cos x sine x on minus cos 2x. And once again, if you look at the formula book on page 14, you will find there's a formula. The formula says 2 sine a cos a equals sine 2a. So if I swap those around, it's still going to be the same thing. 2 cos a sine a, it's the same thing, is equal to sine 2a. So 2 cos x sorry about that, just need a bit of room. So 2 cos x sine x must be equal to sine 2x. All I've done is replace the a and put it equal to x. So up here now, I'm going to have 2 on this thing here is equal to sine 2x on minus cos 2x. The minus comes to the front, you end up with minus 2 sine 2x on cos x. And once again, we know there's a formula, and it's the same formula as this one. 2 sine A cos A equals sine 2A, except this time the A is equal to 2x. Sorry, there's meant to be a 2x here, and I only wrote x. So because those two angles are the same, and the formula says when those two angles are the same, you double it. So therefore we now know that's going to be equal to minus 2 on, I'm sorry, it's not minus 2, it's minus 2 sine A cos B is going to be equal to sine 2A. So since A is equal to 2x, it's going to be sine on 2 on A, and since A is equal to 2x, it's on 2x, and then we can finish it off. Therefore, the answer is minus 1 on sine of 4x. Now, I'm going to be honest with you, that is a ridiculously hard problem. If you can get any way at all in that one, you have done well. You should now be in a position to make a fair attempt at doing the exercise.